At this point, we're really beginning to get to forms of exponentials that pretty much have to be worked by the rules. And uh, the first rule that I'm going to apply is the power of power rules, which simply says that everything inside the paren is raised to the power that's applied to the paren. I consider this to be a first power of 3 and a first power of 4. So everything is going to be raised to the fourth power. The power of powers rule simply says multiply the power times the power. So it's going to be a 4 times 1 for the power of 3. And notice that that's just this rule here. Whatever the power of the inner number is, raised to the power of outer number is just the product of the two exponents. Then there's a power of m. You can guess what it's going to be while I write 28. And simply 4 times 7 is 28. On the bottom of the fraction, this fourth power still applies to everything on the bottom. So it's still the power of power rule. So exponent times exponent, the power of 4 on the bottom is the fourth power. Simply that's 1 times a 4. The power of x on the bottom is x to the 20th power. And that would be 5 times 4. And then the power of y on the bottom is the 12th power. 3 times 4 is 12. And again, sometimes you see 3 to the 4th expressed as 81. And again, there's no clear rule on when you're supposed to take numbers raised to specific powers and tell that as a specific value or leave it as an exponential. 4 to the 4th power turns out to be 256. You could grab a calculator and do that, 4 raised to the power of 4. And then the power of x is the 20th and the power of y is the 12th. And so this problem, strangely, is considered to be done. So notice that the power of powers rule is just to multiply the exponents together, and that's what you get. The next problem, I could do lots of stuff. I'm just going to say the answer is 1. And the reason is that everything raised to the 0 power is always a 1. Notice that this whole package here doesn't really matter what's there as long as it's not 0. And if you read the instructions at the top of the problem set carefully, it says that you should assume that no denominator is a 0. So they're assuming that this thing creates a non-zero answer. So anything raised to the 0 power is 1. I don't need to do anything except to recognize that this is the form that applies. So that's 2 more. I'm going to work the next 2 on the next video.